So we are going to talk about factoring quadratic form polynomials. These are called quadratic form because the factoring involved is very similar to the factoring for quadratics. Last unit we had common term only factoring like this, like if we had 4x squared minus 10x, you could divide out a 2x and put it out front. You divide out the greatest common factor. Difference of squares. If you had something squared minus something else squared, right? This is 5 squared. And then this is 2x being squared. You end up with something that looks like this. And then trinomials. This is where if you have a trinomial you can see, 3 terms. You see if this number here, if there are 2 numbers that multiply to get you this number and add to get you this number. So in this case, the 2 numbers that multiply to 30 and add to negative 11 are negative 5 and negative 6. This one's a little different. This is where you have to use the grouping or rogue method. I'm not going to go through that here, but that's what the result looks like. So now we're going to see higher degree polynomials. We're not just going to see quadratics, but it's a similar idea behind the factoring as it was with quadratics. So these just have common terms or have a greatest common factor you can divide out of them. So let's take a look at this one, 3x to the 4th minus 36x squared. You want to think of the biggest number that can go into both 3 and 36. Well, that's 3. It's going to end up out front. Then you think about how many x's do both terms share? Or what's the biggest amount of x's you could divide out of both terms? Well, this has 4 x's and this has 2 x's. So they both at least have 2 x's. So you can take out an x squared. And then you have to think about what's left after you divide that out. Well, 3x squared times what would be 3x to the 4th? Well, I need 2 more x's, so I'm going to have x squared like that. And then 3 times what is negative 36? I'll worry about the x squared later. Well, 3 times negative 12, or in other words, you could go negative 36 divided by 3 to get that negative 12. Do I need any more x's? No, I don't, because there's 2 x's being multiplied here, meaning x squared, and then there's 2 x's being multiplied here. So I don't need any more x's in this term. All right, I'm done with that. You guys go ahead and try the your turn. I got for that 2r squared multiplied by r cubed plus 9. Okay, yeah, that's the biggest. 2 is the biggest number that goes into 2 and 18, and they both have at least 2 r's involved. Basically, the term with the smallest exponent on the variable, that's the one you're going to be able to take out. Okay, this has r squared. That's the smallest of the 2 exponents. That's what you're going to be able to take out. Now it's time to factor differences of squares. So if we have x to the 8th minus 100, we have something being squared minus something being squared. Well, what squared is x to the 8th? Well, let's figure that out. We would take the square root of it. Square root of x to the 8th. What could you multiply by itself to get x to the 8th? Well, that would just be x to the 4th. You can basically just divide your exponent by 2. And then for the 100, you think of what would be the square root of that. Well, that's going to be 10. So this factors to x to the 4th plus 10 times x to the 4th minus 10. All right? This one down below here, now when I look at this, there's no way you can multiply something by itself to get an odd exponent there. So there must be something else going on here. And I notice, oh, look at that. There's a number that goes into both these, and they both contain an x. So we should factor out a common term first on this one. So you should check for that first if you can factor out a common term. So yeah, 3 goes into both of these, into 12 and negative 3. And also there's a single x they have in common. So that's my GCF. I'm going to divide that out. 3 times 4 would be 12, and then I would need 8 more x's, so x to the 8th. And then 3x times what is negative 3x? Well, that'd be negative 1. Now the inside here, it's possible I can still factor that. This is a difference of squares. There is 4 is a perfect square number. This is an even exponent. So that means I can take the square root of it and get something. There's some expression multiplied by itself that's 4x to the 8th. Well, that'd be 2x to the 4th. And then, of course, the square root of 1 is just 1. Notice we, again, ignore the negative here when we do this. And now this factors, now I have the 3x here that I need to bring along, but then this factor right here splits into 2x to the 4th plus 1 times 2x to the 4th minus 1. Now you guys do the your turns now. All right, here's what I got for those answers. X to the 6th minus 25. I got x to the 3rd plus 5, x to the 3rd minus 5. You might always notice that this exponent here is half of this exponent here. All right, and down here, 81x squared minus 1 comes out to 9x plus 1 times 9x minus 1. Yeah, speaking of that this exponent here is always, this exponent here is half of this one. Or in other words, this is twice that one. That's what this formula up here was talking about. Okay, so yeah, if you this exponent here, if you multiply it by 2, you get that one. Or in other words, you take this one, you cut it in half, you get these, right? That's what that's describing there. Okay, the next type of factoring is factoring trinomials. We have x to the 4th minus 15x squared plus 50. So it's very similar to when we had quadratics. There is no leading coefficient here. Well, the leading coefficient is just 1. So we can just jump into doing this. We find 2 numbers that multiply to c, which is 50, and add to b, which is negative 15. So depending on how confident you are with your multiplication tables, this might come really quick, or you might need to sort of list out all the factors of 50. Either way, the factors are going to be 10 and 5, and they would both have to be negative, because that's the only way you could have 2 numbers multiply to give you a positive and add then to give you a negative. So it's negative 10 and negative 5. Now, so that means those are the numbers that go here and here in our factored form. But what goes here? We don't have a quadratic here. So x squared is normally what we have here. We don't have that on this one. What you end up with is this. And if you think about it, that makes sense if you multiplied this back. X squared times x squared would be x to the 4th. And then you'd have some x squared terms involved. They would add up to this. And then negative 10 times negative 5 is 50. So that's what it looks like. So this exponent here will match the exponent in the result. Or in other words, it's half of this one. All right? That's what this is showing up here, by the way. Okay. Well, it's actually showing that this exponent is half of that one. But same idea. All right. Let's look at this one down here. This one, unfortunately, now I would check for a common term first. I should have done that up here too, but looking for a common term. Is there a number that can go into 7, 19, and 6? No way. So you're going to have to use the rogue method or factoring by grouping. I'm going to go ahead and show this with rogue. So you go a times c, which is 7 times negative 6, which is 42. We need to find 2 numbers that multiply to negative 42 and then add up to 19. All right. Well, it's not jumping out at me right away. Let's see, maybe, let's see, 6 and 7, no. Let's see, 2 and 21. I bet it's 2 and 21. Yeah, that would be it. One of them's going to be negative, one's going to be positive. The 2 would be negative because we need the bigger one to be positive so that we can get a positive result here. So there we go, negative 2 and 21. Let me then go ahead and write this rogue style. Now here's how this looks a little bit different. You would write, again, half this exponent, just like this was half of that. So you'd go 7v to the 6th minus 2, and then 7v to the 6th plus 21. And then we're going to, again, divide out what we can. This one, you can't divide anything out because just only 1 goes into both those numbers. Here, 7 can go into both those. So we're going to get 7v to the 6th minus 2 times, this will just come out to v to the 6th plus 3. So there's our factored form for that. All right, you guys go ahead and do the your turns. All right, here are the answers for those your turns. Yeah, two numbers that multiplied to positive 54, add to negative 15, negative 9, and negative 6. And again, that 3 is half of that 6, or it matches that one, either way you think of it. And then I had to use the rogue method down here. Yeah, A times C was negative 80. Two numbers that multiply to negative 80, add to 11, or negative 5 and 16. Notice both of the binomials here can be divided by something. We don't run into that a lot, but that happened here. And so this is the result. That is it for this lesson. Also, just really quick, polynomials that cannot be factored are irreducible.